In this tutorial, we will be creating an input controller. However, testing input directly is not only tricky, it is also very impractical. Instead, we will employ the following pattern, which makes development and testing much easier. What you can see here is a UML class diagram. The classes in black are provided by Unity, the classes in blue are the classes we will create in our build, and the rest are mock classes we will be using in our tests. Let's first focus on the getKey controller. First, this is an abstract class. I personally would prefer to use an interface, but abstract classes work better in the Unity inspector. The getKey controller provides three public functions: getKeyDown, getKey and getKeyUp. Their behavior depends on the specific implementation. One of those implementations will be the getInputKey controller. This one simply wraps the input getKey functions provided by Unity. getKeyMock are implementations we exclusively use in tests. They allow us to simulate key presses as we need them without relying on any external code. The input controller then simply uses any getKey controller implementation. In our build environment, we can then plug in the getInputKey controller to get the actual key input. In our tests, we can plug in mock components to simulate input. We'll begin by creating an getInputKey controller script. We use this file to create the abstract getKey controller, which the getInputKey controller should implement. After that, we will be adding our three abstract getKey functions. The getInputKey controller overloads those functions and simply wraps the corresponding input functions from Unity. And our getInputKey controller is done. We will forego unit testing in this case because it is just impractical and the gain is very minor. Now it is time to create the actual input controller. As mentioned in the last tutorial, our tests should always implement our base test class to clean up the scene between tests. Now we create a mock implementation for our getKey controller. It has three lists: a begin list for buttons we just pressed, a stay list for buttons we are holding, and an end list for buttons we just released pressing. The getKey methods now simply check if the corresponding list contains the provided key. By adding and removing keys to a list, we can therefore simulate key presses. Now we have everything in place to write our first test. The name is just a placeholder right now, we will later rename the test. First we need a getKey controller, and for this we will instantiate one of our mock components. We will also simulate a key press A. Next we add an input controller. This input controller should check the key A, and it should use our mock component to query whether a key is pressed or not. Lastly, when the key is pressed, we want to fire an event to increment a counter. After calling an apply method, which should apply the behavior of the input controller, we will assert a count of 1. For now, we will instantiate the event handler within the test itself. Of course, before we run the tests, we need to add all our missing fields and methods. Our first test run fails, as expected, with a count of 0 instead of 1. The minimal approach solution for this would be simply to invoke the event. In our next test, we will simulate that no button is pressed. This means we also expect a count of 0. To satisfy both tests, we now need to check the actual key press. I finally could make up my mind how to name the tests. Currently, we are only checking if a key was just pressed, but we also need to be able to check if a key was just released or is currently being held down. To do this, we add an option enum and an option field. Now we write a test where we hold the A key and check whether the A key is being held. Let's write a first implementation for this so that all the tests we currently have are satisfied. In the first two tests, we didn't change the options value, so it will have its default value down. For all other options, we simply invoke the event. For our next test, we still want to check the hold option, but no key shall be held. And as before, we now simply check against the appropriate input. In our last couple of checks, we'll test against key releases, and we do it in the same manner as we did before. We replace our if-else with a switch statement, which still is quite ugly, but for now it serves our purpose and we can always refactor it later. And the last test now will test against key release, while no key is actually being released. Now, in order to use our input controller, we need to call this apply method at some point. To do this, we create one small other component called update controller, which will be quite helpful in the future. We write our first test, where we use an onUpdate event, which should be fired during the update. For this, we use a counter again and check whether it was incremented. Now in the update, we simply call this event. We also add another test for a fixed update event. And now we call this event in the fixed update. But we encountered an error. This is caused by instantiating only one of the two events in each test. Specifically in the test call on update, we are calling a fixed update on the onFixedUpdate event, which is null. One solution would be adding a null check. Personally, I dislike being too cavalier with null checks. So I added two tests to make sure that those events are instantiated, and I used their field definition to call their constructors. Now we can finally put everything together. First we create an input game object and add the getInputKey controller. Now we add child objects, each dedicated to a certain input. We add input controller, update controller, and we can also remove those buttons. We want to move forward by holding W. I find it best to update the movement in the fixed update, so we use translate fixed delta. Now we simply need to apply this behavior in the fixed update. This process needs to be repeated for the other movement directions. First we set the keys for the directions, and set the corresponding callback. And finally, in play mode, we can now move around with WASD. In the future, we will modify this input controller so we can, for instance, handle key combinations. I have also refactored the source code because I really dislike branching with if-else or switch cases. The updated source code can be found in the repository. But that's it for this tutorial. Next time we will use scriptable objects as a communication layer between game objects. Let me know what you think, and thanks for watching.